If x is the average arithmetic mean of m plus 9, y is the average of 2m plus 15, and z is the average of 3m plus 18, what is the average of x, y, and z in terms of m? Just as a quick reminder, another term for average is arithmetic mean, so don't be surprised if that happens, if you see that in a question. And now just quickly remind ourselves that to find the average of anything, you want to add everything together, like the sum of all the things added together, divided by the number of items that you have. That's the idea behind average. So again, you can see every question has a concept. This one, the concept is average. So with that said, let's try to wade through all of this stuff that's given. Looks like there are 3 different averages given here. So it looks like x is the average of m and n. All right, and then we are given that y is the average of 2m and 15. And there's a third thing given here. It appears to be z is the average of 3m and 18. So we have 3 different averages. Each of them has 2 items being averaged. We're going to apply our knowledge here, starting with x. X is the average of m and 9. So we would have to add m to 9 and of course divide by 2, the number of items. And then the next one is y. Y is the average of 2m and 15. Of course, we're going to divide that by 2 because that's what you do when you're averaging stuff. Just divide by the number of items. Third thing is z is the average of 3m and 18. Once again, dividing this by 2. So we go on and read the rest of this, and it says, the question itself is, what is the average of x, y, and z in terms of m? Okay, so we want to find the average of these 3 items, x, y, and z. And to find the average of anything, just one more time, you add those items together. So x plus y plus z, we want to average those. That's what this question is asking us to do. So we have to use that. Let me move this a little left here so we have more space to work with. There's a lot going on. So let's plug those numbers in. We would have, for x, we have m plus 9 over 2, plus the y value is 2m plus 15 over 2, and for the z we have 3m plus 18 over 2. So that's this numerator part. We've just added them together, and then we have to divide all of those by 3 because that's how you find the average of anything. So let's go ahead and try to do this problem. So focusing again on this numerator, we are lucky because every one of those fractions has a denominator of 2, so we have a common denominator. That means we can combine these like terms. So m plus 2m plus 3m is 6m. So we have 6m. And then we've got 9 plus 15 plus 18. That appears to be 42. So 6m plus 42 over 2, because they all have a denominator of 2. And then still, that whole thing is still being divided by 3 because we're averaging. Let's move this up here where we have a little bit more room. So you may remember that when you have this funky looking fraction, we have 6m plus 42 over 2, that's being divided by 3. Remember what we said is if you have this complex fraction, make the fractions look balanced. We can do that by giving this 3 a denominator of 1. And with that said, the shortcut was we multiply the 2 outside terms. So it would be 6m plus 42 times 1 over 2 times 3. It's the outside terms over the inside terms multiplied. So 6m plus 42 times 1 is just 6m plus 42. And then 2 times 3 is just 6. And when you look closely, you find that 6 goes into both the 6 and it also goes into 42, which means we can simplify this further. So 6 goes into 6 once, and 6 goes into 6 once over here. 6 goes into 42 7 times. So we are left with m plus 7, which thankfully is one of the answer choices, making B the correct answer to this problem.